Welcome back. This is the third lesson recording for IM1, October 27th, 2020. So where we've left off is this card number 13 of Desmos, and we're trying to create a total area of 48 square units. Yes, I decided to use 6 and 8, but you could have used different numbers too. So you could have used something like, I don't know, 2 times 24, or you could have used 4 times 12, or you could have used 3 times let's say 18, 16. Okay, so many different combinations. I just happen to have chosen 6 times 8, and I knew that I had to create 6 as the width and 8 as a length total, and then I just broke it up as 3 and 5 for the length and 4 and 2. So that means the length is going to be 3 plus 5 here, and the width is going to be 4 plus 2. And again, yours will be very different. Okay, and then also express the total area as the sum of the 4 individual parts of area. Well, the area here is 12, so that's going to be 12. Area of this orange is 20. Area of this little orange is 6, and the area of the little blue is 10. If I was to add them all up, 12 plus 20 is 32. 32 plus 6 is 38. 38 plus 10 is 48, and that's what we wanted. Okay, so do both ways provide the same answer? Yes. Why? Because we are really dealing with the same area. It's the same rectangle. The area is going to be the same whether I am calculating as width, the total width times total length, or if I break it up into 4 little different rectangles which add up together. Okay, so let's move on to the next card. Okay, so then card number 14. Create a different rectangle with a total area of 48 square units also. Okay, when done, enter the area of your rectangle as the product of two sums. Okay, so this time I want to do, I don't know, maybe 4 times 12. How about 4 times 12? Okay, so I want the width to be 4, so I can do 2 and 2. Okay, let's move this to be 2 and 2. Okay, that means I need the length to be 12, so I can do this as 6 and 6 or 7 and 6. Let's do 6 and 6 just to make it easy for me. 6 and 6, and I have, what is this? What's the length? I have 2 plus 2 here, and 6 plus 6. So I am multiplying 6 plus 6 times 2 plus 2, which is 4 times 12. Also enter the sum as the sum of the 4 parts. What is the area of this little blue rectangle? That's 12. Area of this orange rectangle is 12, and another 12 here, and another 12 here. 12 plus 12 plus 12 plus 12 is 48, and yes, it does provide the same answer. Then number 15, use the 4 draggable points to create a rectangle with 4 sections and total area of 120 square units. Okay, so I want 120. How am I going to create that? Okay, I can do, I don't know, say 6 times 20. 6 times 20, that would work. Okay, so then I need to make the width 6, so I am going to move this to maybe 4 and 2. 4 and 2 would work. Okay, and I want the length to be 20, so I could make that a combination of, say, 9 and, okay, so this does not go very far. Okay, so maybe that's not a good one. Okay, maybe 20 is too big. Let's do something smaller. Okay, how about 15. 15 times what is, so 15 times 2 is 30. 30 times 4 is 120, so it's going to be 8 times 15 will be 120. So let's change this to let's do 6 and 2. Okay, so that will be 8, and I just need to make 15 here. Let me leave the 9 here, and then I can just change this as no, let's change that to 7 and 8. Okay, 7 and 8 comes to 15, and 6 and 2 gets you 8. So that becomes 7 plus 8 is the length, and 6 plus 2 is the width. Okay, and the sum of the parts will be 42 plus 48 plus 14 plus 16, and they should all add up to 120. Great. Okay, so let's take some notes now. Okay, so if I was to look at this area model, okay, then now if I was told that this length is 4 units, and this length is 7 units, and this length is 8 units, and this length is 5 units. Okay, so the area as a sum of its parts, that means I need to figure out the area of this blue rectangle, which happens to be 4 times 7, because width times length is 4 times 7, and then area of this orange rectangle, that's going to be 8 times what is this length. This is going to be same as this length here, so it's going to be 7, so 8 times 7 here, and then this orange rectangle is going to be 4 times 5, 4 times 5, and then 8 times 5 again, so 8 times 5. So we call that the area as a sum of its parts. And then area as, if I was to look at just the length of this rectangle, that's 4 plus 8, that's the total length. And then 7 plus 5 would represent the expression for the width, so 7 plus 5 here. Okay, so then, and we will call that the area is a product of length and width. Okay, because we are multiplying the length. 4 plus 8 represents the total length here, and 7 plus 5 represents the total width here. Okay, so we call this the area as a product. And if I just put those two together, because we're talking about the same area, you know, whether you break it up into 4 bits or we consider it as one big giant rectangle, it is really the same area that you're talking about. Because we're talking about the same area, we can put these two equations, two expressions to be equal to each other. And that's what I did here. And the left hand side represents the area as a sum, because area is a sum of all the parts, okay, little rectangles. While is the green on the right hand side represents the area as a product, because it's the area found by product or the multiplying of length and width. Okay, so then let's extend this a little bit. I want you to tell me in private chat, if I have this rectangle and I am told now the length is 3x, okay, 3 times x is my length and the width is 4. Before we just multiply length and width to find the area, what is the area of this red rectangle now? Okay, so length is 3x, width is 4, so you just multiply the two together and you get 3x times 4, which is 12x. So I know the area is 12x units squared. What about this? Okay, what if I was told to tell you the length is 5x here and the width is x? Again, we just, to find the area, we just multiply length times width. So the area is 5x times x, which is 5x squared. Now let's extend this into from Gabriella's notes to Tommy's area model. Okay, now we are going to bring in some variables. Okay, so instead of just dealing with 6 plus 12 or number plus number, let's bring in a variable and see how that makes a difference. Okay, so x is a variable. So what is the length and width of this rectangle? What is the length? Total length? Well, it was before, if this was 6, we just say it was 6 plus 12, right? But now the length is x plus 12. So the length is x plus 12. What about the width? Width is x plus 7. So then if I was to talk about area as a product of length and width, if length is x plus 12 and width is x plus 7, putting that together, the area is just going to be x plus 12 in parentheses multiplied by x plus 7 in parentheses, because this x plus 12 represents length, this represents the width. Okay? Alright, so then let's consider area as a sum of its parts. To figure out the sum of the parts, the area of each part, we just multiply the length times width of each individual rectangle. So what's this blue area, or blue rectangle area? That's just going to be x times x, so that's going to be x squared. What about this orange area? That's just going to be 12 times x, which is 12x. What about this orange area? Okay, this length is x, because we're told that this length is x, and I know that this length is exactly the same as this length, so that's going to be x times 7, so it's going to be 7x, and then finally this length is 12 times 7 is 84. So the area as a sum of parts becomes x squared plus 12x plus 7x plus 84 here. Okay, but now we've been talking about combining like terms. When you see this expression, what could you add together? You know that 12x and 7x are like terms. That means we can add those together. Just the same way you see 12x here and 7x could be added together. So now the equation, if you set, we're talking about two areas that are exactly the same, so we're going to set the green expression, the area as a product, to be same as area of the sum. So the green expression stays the same, but the purple expression becomes 2x, 12x plus 7x combined is 19x. So it becomes x squared plus 19x plus 84. And the left-hand side is the area as a product. Right-hand side, the purple is the area as a sum. Okay? So you should be taking notes here. Let's try another one. Okay, so what is the length and width of this rectangle? Same thing. Length is, oh, I did not change this. It should be 2x minus 5, and the width is 3x plus 2. So 2x minus 5 should be the length, and width is 3x plus 2. And so then area as a sum of its parts, we just basically need to figure out the area of each rectangle. That becomes 6x squared, negative 15x, 4x, and then 5 times 2 is negative 10. Negative 5 times 2 is negative 10. So the area as a sum becomes this expression, 6x squared minus 15x plus 4x minus 10. And then we combine the like terms, 4x with negative 15x, or 15x plus 4x. And then you get the two equations to be equal to each other, because we're really talking about the same area. So this is representing the area as the product, and the right hand side is representing the area as a sum. Okay, finally, this is your turn, and I would like you to try to do it yourself. Pause the video and see if you can figure out the area as a sum and area as the product. And here are the answers. Okay, and that's it for today. So closure, okay, I want you to write in entry the combining like terms and expressing rectangle as product and sum. That's it for today. Thank you for listening.